All right, let us answer this question before us. It is taken from VCAR 2017, Paper 1, Question 19. Shirley would like to purchase a new home. She will establish a loan for $225,000 with an interest charge at a rate of 3.6% per annum, compounding a monthly. Each month, Shirley will pay only the interest charge for that month. Based on that sentence right there, you should immediately be able to tell me that this is an interest-only loan. The fact that she tells us that we're only going to pay the interest, so interest-only loan. Perfect. We now go into question 19 here, which says, after 3 years, the amount that Shirley will owe is... Well, this now is really testing your understanding of an interest-only loan. Because remember, she's taken out this much money, and each month she's only paying off the interest generated on that. So how much will she owe after 3 years? Well, she's still going to owe the same amount of money, $225,000, because remember, that number stays the same. She's only paying off the interest, which means she's only ever going to owe this much money here. Well, a little bit of a red herring here is this 3 years. It doesn't matter. It could have been 10 years, 40 years. It doesn't matter, this 3 years. It could have been any amount of time. She's always going to owe $225,000 on the loan. Question 20. Let V of n be the value of Shirley's loan in dollars after n months. A recurrent relation that models the value of V in n is what? All right, so we're going to have to figure this out. Let's remind ourselves what it's going to look like. So it's going to look like, and I'm not going to worry about V of 0. I'm just going to go V of n plus 1 is going to look like this. It's going to be the R value times by V of n minus the D value. All right, how can I figure out what the R value is going to be? Well, it's going to be 1 plus little r over n over 100. Now, in this case, I know it's going to be 1 plus, my interest rate was 3.6. It's compounding monthly, so it's divided by 12 over 100. If you chuck that into the CAS, let's do that. We're going to go 1 plus control divide 3.6 divided by 12 over 100 is going to be 1.003. And then I need to find the D value. Now, to do that, what I do is I go take the initial amount and times it by basically the interest. So R on n over 100, right? Because we know that the repayment is simply going to be the interest. So that's all I'm doing here. Now, the initial amount that I took out here was $225,000 times by, it's just going to be 3.6 over 100. I'm going to be a cool kid in how I put this into the calculator. 225000 times it by. Now I'm just going to come up here and I just want to get rid of that here. I just need to get rid of this plus 1. Times it, 675. 675. That will be my repayment. And remember, this is my repayment, but it's also the amount of interest that is generated each month as well, because the interest is equal to the repayment. Looking through those options there, it looks like D. It always messes up every time I do it too close to the edge. But the answer will be D, because I've just got that and that, which is what I found. All right, let's look at the examiner's report now. 19 and 20, right? This was 19 and 20. 61% of people got the first bit right. 46% of people got the second part right. And they do give us a bit of a spiel here. So let's give it a read, shall we? Let's get our highlighter out. This question required students to determine the multiplying factor in the recurrent relation, as well as determine the value of an interest-only repayment. The multiplying factor is 1 plus 3.6 over 12 over 100 is this. The repayment is 3.6 over 12 over 100 times the initial amount is 675. These calculations led to the correct answer of option D. Alternatively, students may have realized that the terms in the sequence of balanced values generated by the recurrent relations would be constant at 225,000 because each repayment would only pay the interest. The balance of the loan after each repayment would be this. Students could have calculated a few terms of each recursion relation using the recursion with technology. Option D was the only recursion relation that resulted in a constant sequence. Okay, so this is the way that we did it here. There was also an alternative way of doing it. And if I'm understanding what they're saying correctly, is you could have put in each of these into your calculator and recognize that the only one that gave you out a constant amount of 225 is this one. Now, that's not the best way to do it, but thinking it through, you could have immediately eliminated A and B because A and B aren't going to be a constant value because you're just calculating interest, so it's going to grow. Then you've just got the option of these three before you. I suppose if you wanted to, you could have put in each of them and see whether or not you get out 225 after each one. But I don't think that's the best way to do it. Another way you could have thought about it is just figured out if this interest rate times by that would have gotten you that out. And if it didn't, then you know it would be wrong. But then even then, that would be, like if we were to do that, again, right here, you can click off now. I'm just kind of mucking around with this question a bit. We could have gone 0.003 times 225,000, and we're going to get 675. So that doesn't work because the interest that is generated by it should be equal to my repayment. And this kind of gave you the answer straight away. So if you did do it that way, the way that I'm doing it right now, you would have immediately identified that D is correct because you get that 675 out there. Cool. So that's probably the best way to do it because you could have immediately eliminated A and B because there was nothing added, nothing subtracted to it. You had no D value. Then you could have just double checked whether the interest generated on that much was equal to 8,100. And it wasn't. It was actually equal to 675, which tells you that D is the correct answer because you've still got this 003 here. Yeah. A bit rambly towards the end there, but hopefully that made sense.